நான் அதே காவல்துறை, இதே நண்பர்கள் போன ஆட்சியில் இருந்தாங்க, இதற்கு முன்பு இருந்தாங்க, வேறு வேறு கட்டத்தில் இருந்தாங்க. நான் ஒரே ஒரு கேள்வி தான் கேட்கிறேன். அது எப்படி கோயம்புத்தூர்ல 98ல நடந்த
Thank you for watching. It's going below the mountain.
The design and everything has been worked out, experiments, scientific team, everything is now in place, and I think it's just waiting for the fun to go ahead. Okay, back to you. Okay, thank you everybody.
Thanks for dropping in, and I think he's obviously upstairs to look at the Eclipse, through the Eclipse glasses itself. Because in Bangalore, fortunately, sky actually is clear, which is quite a rare occurrence. So now I'll ask Fania to take a couple more questions from YouTube chat.
So, yes, please put your questions in the YouTube chat box and we can take them. So, one thing I can tell you about the eclipse is, in general, how eclipses move on the Earth. remember Earth rotates from west to east at a speed of 28 km per hour at the equator. And the moon is also orbiting the Earth from west to east about 28 km per minute. And moon is also orbiting Earth west to east about 61 km per minute. Okay, so during eclipse, moon's shadow also moves from east to west with a speed which is difference between these two, that is 68 minus 28, which is 33 km per minute across the Earth's map, right? So that is roughly how this shadow of the moon moves on the surface of the Earth, and that shadow is basically called the track of the eclipse. And in most favorable circumstances, when the total solar eclipse occurs, the track can be up to 267 kilometers wide, and the totality can last as long as 7 minutes. Right? So that happens in a very, very rare circumstances. And the partial eclipse can be seen from a large area on the Earth's surface, as large as 6,400 kilometers wide and so on. So, typically the totality, the band of the totality could be 100 to 160 kilometers when there is a total solar eclipse. And the shadow can sweep an area of Earth's surface about 16,000 kilometers. Right? So if there is an eclipse, as I said, the shadow moves to different part of the Earth, and from start to end, it could be as long as 16,000 kilometers. And total solar eclipses are rare events, although they occur somewhere on Earth every 18 months on average. It's estimated that they reoccur at a given place only once every 360 to 410 years on an average. So that's like if you are seeing a total solar eclipse at one place, that's only going to be a one lifetime event. And again, I want to reiterate that these eclipses are basically the geometrical effect, and there is nothing supernatural or divine about it. And whatever damage or harm people talk about, that's so. Well, you can see from Leh Ladakh already a very small part of the sun is now seen. Partly it is blocked by moon and partly by the foreground mountains. So this is again a very rare picture that you would see for next couple of minutes or maybe less, because you can see it is shrinking very fast, and in a minute or so the sun would set in Leh. So these are the last couple of seconds that would be visible before the sun sets and this spectacle come to close. Yes, the last part. So we can see that there's only very small portion which is almost now gone now. So that concludes the eclipse from the Leh Ladakh. And we are trying to get the feed from Bangalore because sun is yet to set, and we already had some eclipse going on here, right?
Yes, that's true. So the eclipse started in Bangalore only a few minutes ago, and we're trying to get a feed from upstairs, literally. But as you can see, once the eclipse sets from north, it keeps the shadow keeps traveling downwards and southwards.
Yes.
So while we're getting the Bangalore link, you please continue posting questions, and we will try and answer them while we're waiting. Okay. So how do you visit Leh and Hanley is a question. You'll have to write to us, go on our website, and you can fill up a form for that. Why should we not eat during the eclipse? You can. Shyam's asking, can I watch the eclipse with bare eyes? Please do not do so. it's not safe for your eyes to look at the sun directly. You have to use eclipse glasses or any projection method.
So there is a question on gravitational lensing during eclipse. So remember Einstein's general theory of relativity, which predicts that if there is a heavy massive object in the foreground of a star, then that object is going to bend the starlight. Now that was the theory, and in order to prove that, to give an experimental proof for that theory, Arthur Eddington in 1919 Eclipse expedition planned an experiment to test the theory. So that happened to be the total solar eclipse day in 1919, and when the total solar eclipse happened, they took several images of the sky and with the background stars. And when you take the same images of the same part of the sky 6 months later, you would see that position of the stars in these two images was different. So there was a slight shift in the position of the stars, and that shift was attributed to the gravitational bending which the sun caused to the background star, or the light coming from the background stars. So this is how the lensing happens when you have a massive object in the foreground and the light is coming from a source which is in the background. It's a myth. So I'm also looking at the questions and I would respond if there is any question. So there is a question whether Earth is the only planet which can experience the solar eclipse. That's not quite correct. Remember, eclipse is happening when something is coming in between the Earth and the Sun. Now that can be true for any planet. So if there is some other object which comes in between the other planet and the Sun, that would cause the eclipse at that planet, right? So some of the moons of Jupiter as well as Saturn and maybe also of the Mars can have the similar configurations which may cause the eclipse of or solar eclipse for those planets. So it's not the phenomena which is only observed on Earth, but it could be widely observed on outer planets which are outside the orbit of Earth. Okay. Yeah, if you have any more questions, you please feel free to post it on the chat box in YouTube. While we are trying to get you feed from Bangalore, the eclipse has already started here. Sun has not sun. Our both feeds that were really very successful from IIA Leh as well as Hanley, we have seen the spectacular eclipse happening there. And right now the sun has already set. So the feed from those two places has stopped. And we will try to have it from here, from Bangalore in a short while if we are able to do that. What happens if Earth stood motionless and sun and moon rotate about it? No, that's a hypothetical question. Sun is the massive body, and if you look at any other objects in our universe, it's always the lighter bodies which go around the massive bodies. And by the way, nothing can stand still in the universe or in the space. They are always moving. Even the sun and our solar system is going around the galaxy. So it's also, even though we say sun is at the center of solar system, but it's not stationary. In absolute space, it is not stationary. It's still going around the Milky Way. So, some more question. The length of the solar eclipse. The world record. So, as I said already, under West circumstances, the total solar eclipse could last as long as 7 minutes, 6.5 to 7 minutes, and that's also roughly the record. There's a question that Saturn has 83 moons, and can we see 83 eclipses on the Saturn? So remember, eclipses can vary depending on what is the size of the moon and how far it is from the planet, right? So if the moon is really small and it is far away, then you might see it transiting in front of the sun, but not really causing any the shadow on the planet. So again, the occurrence of the eclipse would also depend on in what plane these planets are revolving, or the moon are revolving around the planets compared to the orbit of the planet around the sun, right? And everything is not in same plane. The moon's orbit around the planets can have a tilt with respect to the orbit of the planet with respect of the planet around the sun.
Yeah, so there are a few questions which are on the same topic, so I'll just club them together. While we're so we're getting a feed from the terrace of our institution in Bangalore. So please stay back. You can see now. You can see it. Thanks, Prasanna, for getting that done. In Bangalore, the eclipse started only 10 minutes ago, and the maximum coverage of the sun in Bangalore would only be around 11%. And somebody's asked why is it seen in Bangalore much after Ladakh, and that's a good question because as the moon and the earth go around the sun, the shadow of the moon travels across the earth's surface and it's traveling in the direction from north to south, right? So it started in Russia first, then Kazakhstan and Central Asia, and then it crossed Ladakh, and then it's now crossing Bangalore and South India, which is why you're seeing a time gradient in the way the eclipse is traveling. And in some of the eclipses, you would see that the direction of the shadow of the moon on the Earth's surface will be different, and therefore the order in which you would see the eclipse from various parts of the globe would also be different. There was a question about Saturn's. Did we talk about this amazing coincidence we have of this 400, the coincidence of 400?
Maybe you can tell a little bit about that.
Okay.
Yes.
So, right, people ask why we have a total solar eclipse occurring every now and then on the Earth, right? Now the question is, the moon covers the sun's disk exactly during a total solar eclipse, and you can ask why, right? It ends up being a very interesting coincidence that the moon is able to cover the sun's disk exactly now. The reason is because the sun is around 400 times as big as the moon, right? But the sun is not only 400 times bigger than the moon, it's also 400 times farther than the moon is from us, right? Because of that, the sun and the moon end up having the same angular size in the sky, which is why the moon can exactly hide the sun now. Now, this is merely a coincidence, and you can ask, this is a really strange coincidence to happen, is it natural and so on? It is, because the moon is moving away from the Earth slowly, right? And therefore, the moon was much closer to us before, in which case it would have covered the sun much easier. But as the moon is moving away from the Earth, after like a billion years or so, the moon will become much smaller than the sun as seen on the sky, and then you no longer have total solar eclipses. So we can only enjoy total solar eclipses on Earth for another few 100 million years, which is therefore we're lucky that we can, right? In some sense, it's a coincidence, but it's a happy coincidence, basically. Right. There's another question saying, can the Earth block sunlight and cause the eclipse on Mars? In principle, maybe, but then the Earth's size is so small compared to the sun's disk from Mars, like Banyal just said, that you would not be able to see it visually that easily. But then Ravindra Banyal here is also an expert on what we call extrasolar planets, right? Which are planets which we have discovered now to revolve around distant stars, nearby stars. And when you say eclipses, there is a very interesting and important connection between eclipses and discovering planets around other stars. So maybe you want to say something about that?
Yes. So as you see, we are watching the eclipse when moon is coming between the sun and the earth. Now, when we extend this idea to the stars outside our solar system, and of course, all those stars have planets around them, and now we know for sure that each star on an average has one or more than one planet. Now, as an observer, when we look at these stars, some of the stars and planets will have a right configuration close to the edge that as an observer, you will observe that a planet would cross the disk of the star. Well, you don't resolve planet and stars because they are so far away, the telescope cannot resolve. But by virtue of the fact that the planet passes in front of the stars, it would block certain light of the stars. And now we have instruments, photometers, which are sensitive enough to record that reduction in the intensity. And this is how one of the methods to detect exoplanet works, the transit method. Transit method is nothing but the eclipse caused by the planets around the other stars, which then is the reduction in intensity is recorded by the instrument that are on Earth or space-based instruments. And that's how we usually confirm or validate the presence of planet around other stars. There are other methods also to detect planet around other stars, but the transit method has been the most successful methods, where almost more than 70% of the total planet as of today are detected by transit method. Remember, today the confirmed discoveries are close to 5,200 and more than 6,000, 3,500 are detected by transit methods. And
thank you, Banya. Now, Banyal has been sitting here with us since 4 o'clock, explaining the eclipse to all of us. But I think it's time he went upstairs to see the eclipse for himself. So I'm going to relieve Banyal now. Quickly run out, see the eclipse yourself, have fun, come back.
Yes.
In the meantime, I'm going to ask Ramya and Aratrika to join us. A couple of questions which I think you would like to answer. One is that if you compare the age of the sun to that of the human age, what is the current age of the sun and how long does it take to become a white giant? I mean, I think they mean red giant, right? So basically, the sun's evolution. How old is the sun? What will happen to it? Piyali, Ramya, anybody who wants to take that question?
So yeah, I will answer part of this question. So just like there is birth and death of human beings, the stars also are born and they die and fade off. But the time scale is quite large. We are talking about few billions of years time scale over here. So now the current the current age of the sun is about 4 billion years. It's already 4 billion years old, and it is what we call is in the main sequence stage. So what do we understand by main sequence? This means that the at the core of the sun, there is hydrogen fusion reaction going on, which means hydrogen is fusing to form helium. So that is the reaction which is currently happening, and that is the main sequence phase where the sun is going to spend most of its lifetime in the main sequence. So then once the core is completely converted into helium from hydrogen, so the sun will move on to slowly become the red giant, where it will expand, and this will take another few billions of years. And once the sun attains the red giant phase, I think that is when it will also engulf Earth and other planets in the solar system. After this stage, in a few billion years, we will end up, or the sun will end up as a white dwarf. It will shrink in size, and yeah, the fusion reactions at the core will kindly cease. So that's the phase. When compared to human life, which is only few 80 to 100 years old on an average, the sun will live on for about 8 to 10 billion years.
Ramya, you're muted. Okay. Thanks, Ramya. Piali, would you like to add something to that?
Yeah, I think Ramya has pretty much said everything. So I think the sun is basically in its middle age now. So maybe if the human lifespan is of the order of 80 years, the sun is probably 45 to 50 years old right now, which is what she said. So the sun will continue to shine this way for another 4 billion years before the catastrophic strikes. It becomes a red giant, and then the solar mass is not sufficient enough to form a neutron star or a black hole. So the end stage of the sun's life would be spent as a white dwarf, basically. So the sun is not going to end up as a supernova, but something much less spectacular than that. And after that nova is formed, the outer layers of the sun are shed, the sun will end up as a small white dwarf whose size is actually going to be much, much smaller than that of the Earth. So the Earth's size is around 12,000 kilometers. So the size of a white dwarf comparatively would be around 200 kilometers. So that is how the sun is going to end its life. But before it does, as Ramya pointed out, the sun is going to bulge up so much that it is going to, the size of the sun is going to be similar to the orbit of the Mars. And afterwards it will shed its outer layers and end up as a very small white dwarf. So that is what I wanted to add.
Thank you.
Thank you, Niraj.
Thanks, Piali. Yeah. There's a question. Does eclipse have any effect on satellite communication? It's a good question. Not really, because the shadow of the moon is falling on the Earth, right? If the shadow of the moon was falling on the satellite, then of course its solar panels would not be able to generate energy for that time. So that would be the only effect. But there's another very interesting effect on the Earth because solar eclipses in our modern times when we focusing on green energy, right? So in many countries, a large fraction of their energy comes from solar panels. And if a solar eclipse happens in the middle of the day, for example, like it happened a couple of years ago, there'll be a sudden decrease of energy flowing into the national grid from the solar panels, and therefore they have to take special care to make sure that that doesn't have any adverse effect, doesn't trip the entire grid or something, right? So they have to slowly reduce the power from the solar grid into the national grid and then raise it again after the eclipse. So it's kind of an interesting effect solar eclipses have on our modern life in the context of green energies. There's a question about why can't Mercury or Venus have an eclipse on Earth? So we answered that earlier, but let's handle that again. Aratrika, would you like to handle that?
Yeah, of course. So the thing is that both Venus and Mercury, those are pretty small planets, and both are quite far away from us as compared to the Moon and Earth's relative size and distance. So what the thing is, they do form shadows on Earth, but they are almost negligible. They cannot really be observed by us. So those are mostly called transits, not eclipses in that sense. Yeah, I hope that's enough.
Yeah, thanks a lot, Aratrika. Yeah. So we do have Mercury and Venus transits. There won't be any of them soon. We had a couple of Venus transits last decade and also a couple of Mercury transits. Nowadays we observe transits because they look beautiful. The eclipse looks beautiful, so does the transit, of course. But the transits have a historical importance. It was by measuring the time of the Venus transit from different parts of the Earth that we first knew how to calculate the actual distance between objects in the solar system. So till then, we only knew the relative distances. We knew that, for example, if the distance between Earth and the Sun was 1, then Earth and Venus is so and so, Jupiter and Sun is so and so on. Everything was relative to a given distance. But to calculate the absolute distance between objects in the solar system, Venus transit was what was used in the 1800s to calculate them accurately. Now, of course, there are much more accurate ways of doing so. What is the effect of radiation skimming across the moon falling on the Earth? Not really. The radiation skimming across the moon falling on Earth is almost negligible. It would be because of gravitational lensing, and that's extremely small because the moon's mass is very small. Anyway, it would still be far less than without an eclipse, right? So there is no effect, there's no harmful effect of the eclipse on us. There's no extra radiation coming from the solar eclipse which will affect us. You can eat, you can drink, you can go out, you can do whatever you want to, and so on. It's an interesting question about the impact of the eclipse on the waves in the ocean. That's an interesting question. Of course, we know that waves are, I suppose you mean tides, so I'm going to assume you mean tides, right? Tides in our ocean are caused by the moon's gravity as well as sun's gravity, and we know that the moon plays a much more significant role in affecting the tides in our oceans compared to the sun. And of course, when the sun and the moon are roughly the same direction, the tides add up and you get stronger tides. And that is true for every new moon, for example, right? During full moon, you get less tides because they're in opposite directions. So the tides during a new moon and during an actual solar eclipse aren't that different because the moon is almost the same direction as the sun within 2 degrees or so. So there will not be much noticeable effect on tides because of the eclipse over and above what happens during a new moon anyway. So as you can see, the eclipse is ongoing in Bangalore, and that is because we're far south, and the shadow of the moon is moving southwards from Russia down to South India, and therefore, as time went by, we started with the eclipse in Russia, then Kazakhstan, Central Asia, Ladakh, Central India, and now and sun is set in Ladakh now, and now we are seeing the eclipse from Bangalore. In fact, we're seeing it from the terrace. There are Prasanna and other colleagues of his are upstairs sending us the live stream of the eclipse, which is being laid by Swastik, who's here. I request Swastik to come here and say hello because he's been doing a lot of work, and I think people should see him and say hello. Swastik is a student here. He's doing his PhD in IIA, and that's it. And so he and Amit have been behind the computer since 4 o'clock, and it's because of them we'll be getting the live stream from across the world. So thanks.
Yeah, hi everyone, and here I'm meeting. I'm still alive.
Yes. So as you can see, the sun sets in Bangalore at 5:55, but it will set probably a few minutes before that here because we have some trees and buildings in the horizon. It's 5:40 now, so we will continue this till sunset in Bangalore, and then we'll stop this transmission. We still have quite a few of people with us now. Thanks for staying so long. I will and Randeer Singh says hello, Swastik. I don't know if you know him.
Okay. Yeah, hi from my end.
Yeah. So somebody's asked whether shadow of the moon falling on the surface of the sun is called a solar eclipse. No. The light falling on the moon is because of the sun, and therefore the shadow of the moon will always be behind the moon as seen from the sun, and therefore it cannot fall on the sun. It's like saying shadow of me because the sun can fall on the sun, it can only fall below me, right? So that's how it is. Yeah. So there are some questions about how come ancient Indians were able to predict eclipses without telescopes and so on. That's a very good question. So astronomers from across the world in many cultures were able to predict eclipse very accurately much before telescopes were invented. And these were because they had good models for the motion of celestial objects around in the sky. So Indian astronomers, starting from Aryabhatta up to the Kerala School of Mathematics, and even later, if you look at Patani Samanta Chandrasekhara in Orissa, have had perfected or had continuously updated the methods of calculating the paths of the moon and the sun in the sky, and therefore the eclipses for many centuries. Similarly, it was also done, for example, in Europe, in China, in Mesopotamia, long back, in Egypt, and so on and so forth, in Greeks and all that. So the model they used was that they would model the objects going around the Earth in a circle. But that was not quite accurate because the Earth is the one which is going around the sun. Therefore, they had to modify these circles with what we call epicycles. And then they would look at the predictions of where the planets or the sun or moon should be, let's say next month, with what actually happened. And they would then notice there are some errors. They would then modify the epicyclic models and so on. So they kept modifying these models across many centuries, across various cultures, including India. so that it agreed better and better with the observations. But of course, once we realized globally that it was the sun that is the center of the solar system and not the earth, then we threw away the epicyclic model and came to the heliocentric model, where of course the calculations became much, much easier. And now, because we can use dynamical equations from Newton's time, we can add in the effect of very small perturbations. For example, the effect of Jupiter on Earth's orbit, or effect of Saturn on Earth's orbit, and so on. And therefore, we can refine our predictions even more and predict eclipses much more accurately than we could before. But there's one very interesting application of ancient Indian eclipse observations, which is pioneered in Bangalore actually by Dr. B.S. Shailaja, who is the director of the Jawaharlal Nehru Planetarium in Bangalore, and her student Geeta Kaidala. They looked at stone inscriptions across Karnataka and Andhra dating 2000 years ago, so last 1000 years, in old Kannada. And some of them would be recording, gifts by the kings and so on during an eclipse, right? And they would then mention, okay, this village, this eclipse was seen at this time, and this is when the king gave so much money to the temple, and so on. And this kind of thing is found in other parts of the world as well. So what people do, including Dr. Shailaja and a student in Bangalore, is that we know when the eclipse should have occurred and where it should have occurred, let's say 800 years ago. You compare that with the records, and then you can check if there's any error. And any error can then be possibly attributed to perturbations in the moon's orbit itself. These are called delta T studies, and it's very important, right? So if you have eclipse records in stones or parchment or whatever dating back 1000 years, 1500 years, you can use that to have constraints on how much the moon's orbit has changed by very little bit. And this is something which is being done in India as well, increasingly, along with other records in other parts of the world. Will there be an impact of climate change on the eclipse? No, not really. If, except that, our atmosphere might get very, very hazy and murky and we will not be able to see anything, but there's no effect of climate change. I'm just holding the fort till people come back from upstairs after they see the eclipse. So I just keep answering questions till sunset. Are there any electric and magnetic field effects of the eclipse on Earth? No, there's not really. Not on the Earth's surface. Impact of eclipse on astrophysics in India? Oh, there's plenty. So eclipses are, as you're seeing, beautiful events, right? They're absolutely marvelous events, and there's something which excites everybody, right? So a lot of people I know got interested in science or astronomy because they saw an eclipse safely at some point, right? But astrophysics development in India itself was influenced very, very deeply by eclipses. The total solar eclipse on 18th August 1868 passed through Andhra Pradesh. Okay, and in Machilipatnam, and then this just when spectroscopy had been invented, right? So Pierre Janssen had set up a camp in Guntur in Andhra, and Norman Watson, who was the director of the Madras Observatory, had set up a camp in Machilipatnam in Andhra to see the eclipse, and in particular look at the spectrum of the corona and the chromosphere at totality. And he ended up discovering the element helium during his eclipse in India. So that's a very important, Indian connection to solar eclipses, right? Do eclipses help the planet in any way or useful? No, they're not useful, but they're beautiful. And I think a lot of things can be beautiful and not really useful, and that's part of why things are beautiful, right? So you can. So somebody asked about Varahamira and so on. So Aryabhatta had actually mentioned very clearly that eclipses are caused due to the shadows of the sun and of the earth and the moon falling on each other. Okay, and he told you how to predict that. Varahamira and Bhaskara did not agree with him a little bit. Varahamira and Bhaskara invoked Rahu and Ketu. Aryabhatta did not. Much later, Lalacharya, who's another famous Indian astronomer, said the same thing. He said, look, eclipses are not caused because of demons and so on. That is a story, but eclipses are caused only because of shadows of the earth and moon falling on each other. And a lot of people in that age made fun of Lalla. Lalla was a very famous astronomer who lived, I think, 800 years ago in Gujarat, in present-day Gujarat. And people made fun of him, but he said, no, I know, I can observe eclipses, I can understand how they cause, and he insisted that the stories you have about eclipses are stories, but we understand the science behind them. and it is because of shadows, and therefore they're perfectly harmless, right? So so I would rather follow Aryabhatta and Lalla personally. So Ravindra Panyal is back here. Do you want to tell us how the eclipse was upstairs? You can turn the video on.
Okay.
And tell us what you saw.
Yeah, so I had just gone out and saw the last part of the eclipse from Bangalore, and it was spectacular. We had like several students there and some visitors as well. So I would also urge people who are living in the southern state, and if they have a clear sky, they could probably step out and have the last glimpses of this eclipse, because the next one is going to happen maybe 2 years down the line. So this would be the last and the right opportunity to take the final glimpses of this year's eclipse that is visible from India. Right now, only from southern state. I'm sure most of the northern state, the sun has probably already set.
Yeah, and it's setting in Bangalore as well.
It's about to
I
set
think
in
it's set in
Bangalore.
Bangalore. The sun looked weird because part of it is covered by the buildings and the moon.
Yes.
There you can see the sun being swallowed up by some apartment complex, while it's also being swallowed up by the moon from the other side.
Yeah, can imagine now
So-
anything.
So we'll wait till the sun sets in Bangalore, and then we'll stop this live feed. This is the last view of the eclipse sun from Bangalore currently. It's already set in North India.
So there's a
And
question.
in Bangalore, the maximum is around 11%. So 11% of the sun's disk is covered by the moon. There we see the last remnants of the sun. And I also want to introduce you to Amit, who's been behind the computer along with Swastik, bringing us a live stream from 3 different places in India and 2 abroad. So that's Amit, say hello.
Hey guys, nice to be here and be a part of all this.
So now we
Event.
see that the sun is set.
Yeah.
If you're at the apartment complex there, you will still see the sun eclipse, but then they're hiding it from us. So last words, Panyal.
Yeah, so I just want to say that these solar eclipses, they are natural phenomena, and they are not harmful, neither they are anyway auspicious. They are beautiful, as Neeraj has said, and we should not deprive ourselves from these wonderful spectacles